All right, today we're going to be talking about acceleration. And again, just like I mentioned with speed and velocity, and how I said that in everyday life, we tend to use the term speed and velocity interchangeably, but they're really not when we're thinking about physics. Acceleration in physics is different than what we think of it in everyday life as well. When we think of acceleration, we just think that something is speeding up. So, if you hit the gas pedal in the car, you are accelerating. If you hit the brake pedal in the car, you are decelerating, you're slowing down. But in physics, acceleration simply means that we're changing the velocity over a period of time. And so acceleration is going to occur when either your speed changes, so you could speed up or you could slow down, and that would be acceleration. When your direction changes, if you're going west and suddenly you turn north, with your direction changes, then that's also acceleration, because just like velocity, acceleration is a vector quantity and it depends on direction. So speed changes, direction changes, or both of them could change. And all of these would indicate that we have acceleration because our velocity is changing. And that's really what acceleration is. It's a change in velocity. And so velocity can change either by how much or by the direction, okay? So the formula that we use to calculate acceleration is v sub f minus v sub I over t. And what that little subscript means is it's telling me which velocity is which. If the velocity is changing, I had to have one velocity at the beginning and another velocity at the end. So this probably should look familiar from when we were doing displacement earlier. We said that the change in displacement was the final position minus the initial position. Well, this is basically the same thing here. I'm going to take the final velocity and I'm going to subtract the initial velocity from it. So you have to be careful to make sure that you get these in the right order. It's the final minus the initial. You want to make sure that you don't flip them backwards, and I will show you why here in just a second. The units on acceleration are something that tend to confuse students, so I want to try to explain to you how these units work. Let's assume that you're moving at 10 meters per second and you hit the gas pedal and you start accelerating, okay? So when you first start at time equals 0, you're going to be at 10 meters per second. So if you've got your stopwatch running, 1 second later, you look down at your speedometer and you see that you're up to 12 meters per second. And when you're still pushing the gas pedal, and then you look a little bit later, and at 2 seconds, your time or your speed has gotten up to 14 meters per second. Well, you can see that what's happening here is that every second I've gained 2 meters per second in my speed. Right? I gained 2 from 10 to 12. I gained 2 more from 12 to 14. So I am accelerating and I am going up in speed. And so what that means is that I am accelerating at a rate of 2 meters per second for every second that goes by. And so 2 meters per second, per second, that means the second would be in the denominator again. And so what that gives me is 2 meters per second squared, because seconds times seconds gives me square seconds. So that's what this unit means. It's 2 meters per second, and it's changing that much every second that goes by. So that's why you have a squared in this time in the denominator. Okay, so units 2 meters per second squared or meters per second squared. It could be kilometers per hour squared. It could be centimeters per year squared. Any type of unit. You have a distance unit on the top and a time unit on the bottom. That is squared. So we have some sample problems that we're going to be working. And so we'll start with the first problem on the list here. It says a rock is dropped from a bridge into a river. It starts out with 0 initial velocity and hits the river 2 seconds later, traveling with a velocity of 19.6 meters per second downward. What is the acceleration? Okay, so acceleration equals the final velocity minus the initial velocity over time. Now, what is happening to this rock here? If this is my bridge and the river's down here and I'm standing up here and I'm dropping a rock and the rock goes down here until it hits the water. When I'm holding it in my hand, it does not have any velocity. So its velocity up here is 0 meters per second. No velocity, it's not moving. Then I drop it, and it doesn't say I'm throwing it, I'm just dropping it, okay? I'm dropping it, and when it hits the water, it now has a velocity of 19.6 meters per second, and it's moving downward, so the direction is downward. And it wants to know what the acceleration is. Well, it has to be accelerating because here it doesn't have any velocity, and here it does have velocity, so that means that there has been a change in its velocity, a change in its speed. Direction hasn't changed, but its speed has definitely changed. Okay, so let's plug the numbers in here and see what we end up with. So the final velocity when it hits the water is 19.6 meters per second. The initial velocity was 0. And the problem told me that it hit the river 2 seconds later. Okay, well, 19.6 minus 0 just gives me 19.6. So I'm going to have 19.6 meters per second divided by 2 seconds. And then when I divide that out on my calculator, I will end up with 9.8 meters per second squared. And because this is a vector quantity, we have to have a direction on it, and it is going downward. Okay, so 9.8 meters per second squared downward. All right, now let's look at the second problem because it's going to be a little bit different. So we'll get rid of the bridge and the river and the water. And now we have a bicyclist. And he is traveling down the road at 18 feet per second to the east. And he sees an obstacle in the road ahead, so he hits the brakes. In 1.8 seconds, the cyclist has come to a complete halt. What is his acceleration? Now remember, acceleration, it says he's traveling and he comes to a stop. That sounds like deceleration, but in physics, there is no deceleration. It just means that his acceleration has changed. So if I have a bicyclist, okay, yeah, I know, it doesn't look like a bicycle, sorry. So here's his road, and he is traveling at 18 feet per second to the east. There's an obstacle in the road, and he hits the brakes, and so by the time he gets here, he has completely stopped. So here, what's his velocity? Well, it's 0 feet per second. He's not moving anymore because he doesn't want to hit this obstacle. And how long did it take him to do that? It took him 1.8 seconds as he's going from here to here. So what kind of acceleration did he have? So his acceleration, v sub f minus v sub I over t. Well, what was his final velocity? Well, when he got done, he wasn't moving anymore. So his final velocity was 0. His initial velocity was 18 feet per second, and it took him 1.8 seconds. That was his time. So what's that going to give me? Well, my acceleration is a negative 18 feet per second divided by 1.8 seconds, which is going to give me a negative 10 feet per second squared. Negative 10? How can acceleration be negative? Well, it's slowing down. And so what this means is that if acceleration has the opposite sign of my velocity, that means that I'm slowing down. In fact, that's an important point that I'm going to make sure I put over here. If velocity and acceleration have opposite signs. Okay, and it doesn't just mean if acceleration is negative, because as we saw before, my velocity could be negative too. It depends which direction, what my displacement is. But if velocity and acceleration have opposite signs, what that means is that the object is slowing down. So that will be one way that you can check and make sure that you've done the problem correctly. In the first problem, we said, well, the rock started out not moving and it ended up moving. So that means the acceleration should be positive. Here, I started out moving and I came to a dead halt. So he should be slowing down. So if this is positive, acceleration should have been negative. That makes sense. Okay, so what that means is that the acceleration, because it's a vector quantity, is acting in the opposite direction of the velocity. Okay, acceleration is acting in the opposite direction of the velocity. So if my velocity was 18 feet per second to the east, my acceleration is 10 feet per second squared to the west. So I can really express that either way. I can express it with a negative sign, or if they've given me a direction here, I've got to make it the opposite direction in the answer. Okay, we are going to do one more example, because sometimes mean old teachers will throw a monkey wrench into your problem and expect you to catch it. So we're going to do a problem like that so you can see what that looks like. We have one more example problem there to look at. I'm going to leave that up there because I would highly recommend you copy that down if you have not already. Okay, so just pause the video if you need to take time to copy that down. All right, the last problem says a sports car travels from 0 to 60 miles per hour north in 6.1 seconds. What is its acceleration? Okay, so I have my sports car. I know, doesn't look like a sports car. Okay, so the sports car is heading north. He starts out at 0 miles per hour. And he goes this way, which is north, and he gets up to 60 miles per hour once he gets up here, and this whole thing has taken him 6.1 seconds. And so I want to know what the acceleration is here. Now, you have to be careful on this one, because before in the problems, in the first problem on the rock, I gave you a velocity in meters per second and a time in seconds. The one about the bicycle, I gave you a velocity in feet per second and a time in seconds. But now you have a velocity in miles per hour and a time in seconds. That's a problem. I can't divide hours by seconds and end up with anything meaningful. So if you're going to do a problem like this, you have to make sure that your units are going to match. It will be easier to change seconds to hours than to try to change this, since there's a combination of units in it. So the first thing I need to do is I need to change this to hours. So if I have 6.1 seconds, I'm going to put that over 1. I need seconds on the bottom. I'm going to put minutes on the top. There are 60 seconds in 1 minute. And then if I put minutes on the bottom and hours on the top, there are 60 minutes in 1 hour. And so if I do that, I take 6.1 divided by 60, and I get 0.00169 hours. Okay? Now that this is in hours and this is in hours, now I can find the acceleration. So if both of my velocities are positive, the car is speeding up, what should be the sign on my acceleration? Well, yeah, it should be positive, because If it's speeding up and this is positive, then the acceleration should also be positive. So let's see. So if I have v sub f minus v sub I over t, my final velocity is 60 miles per hour. That's where he ends up. I'm going to subtract his initial velocity, which is 0. And I'm going to put that over the time, which I changed to hours, 0.00169 hours. And so 60 minus 0 is 60. So take 60 divided by 0.00169. And you should be aware that if you divide by a really, really small number, you end up with a really, really big number. So the final answer here is going to be, make sure you try this so you get the right answer, 35,503 miles per hour squared. So he's got a pretty good rate of acceleration going there. Which direction? Well, the car's going north. The acceleration is positive. The velocity was positive. So that means that this is also to the north. Okay, so if your acceleration and velocity have the same sign, you're going in the same direction. If they have opposite signs, then they're going in the opposite direction. Okay, if they have opposite signs, the object is also going to be slowing down. If they have the same sign, the opposite or the object is going to be speeding up. Okay, so as you are working these problems, I would suggest that you try and predict when you have the problem set up, okay, should I come up with a positive acceleration or should it be negative? So ask yourself that question as you are in the process of working out the problems for today.